Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. If there were 39 people on the bus and 4 people got off the bus, that would leave 35 people remaining on the bus. So the fraction of people staying on the bus is 35 out of the 39 people on the bus. So our answer is, as a fraction, 35 over 39. And we can't cancel that any further. So we need to first of all understand what a cube number is. So a cube number is the answer to when you get 3 integers or whole numbers and we multiply them by themselves 3 times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. So we can write the factors of 6 by working out 2 numbers that multiply together to make 6. So 1 times 6 and 2 times 3. So 1, 2, 3 and 6 are all the factors of 6. The only number that is in our list is the 2. Whenever we multiply 2 negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2, and it will have 30 vertices. So we're told the sequence starts at 20, so our first term will be 20, and we're told that the rule is add 5, so we're going to add 5 to that, and that will be 25 for our second term, add 5 again, and that will be 30 for our third term. When a number is next to a letter, we actually have a times sign there, so I'm going to rewrite this question as 4 times A times 9 times B. What I'm going to do is put the numbers together, so 4 times 9, and then put the letters at the end. Now 4 times 9 is 36, so it would be 36 times A times B, and in algebra we don't put the times signs, so it's 36AB. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So we have an original amount, and this represents 100% of the original amount. The new price, or new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. Bearings questions are normally written as find the bearing of destination from a location. So you can see in this question here that the answer is 275. So the line they're taking it from is this line here, this north line, and they're looking at this bearing here. So we currently are at B, and we're looking at the angle of A. So it is the find the bearing of A from B would be the question. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy, and when I do that I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually it would be 21%, because this would round it up, so 21%. A plane of symmetry is anywhere you can cut a 3-dimensional shape, in this case a cuboid, and put it up against a mirror and it looks like the original shape. So if we were to cut the cuboid here and then put it up against a mirror, it would look like the cuboid again. Similarly, if we were to cut it along here, it would look like the original cuboid again. And finally, if we were to cut it up the top here, down, across the bottom here, and then up here, and put it up against a mirror, it would look like the original cuboid again. Now you might think that diagonal ones will work with this. Diagonal ones only work with cubes, not cuboids. So our answer is 3. To find the angle marked x, we first of all need the formula that the sum of the interior angles is equal to the amount of sides the polygon has, take away 2, and then times by 180. So this has 14 sides, so it's 14 take away 2, which would be 12 times 180. And then when we do that on the calculator, we get 2,100 and 60. Now that's the sum of them, so that will be all of them added together. So to find out what x is, we just need to get that 2160 and divide it by 14. And that's going to equal 154.285, blah, 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 blah. And it says it wants it rounded to 2 decimal places, so that's going to be 154.29. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing. It's timesing the x by minus 6. So we're going to divide both sides by minus 6. So that gets rid of the minus 6 on the left-hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15, so w therefore equals 4. So I'm going to start off just with a quick sketch, and we know that the bearing of b from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them, and let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an x and this a y and written x equals 85 and y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So I'm going to write this out again just to give us a bit more space. And the way we're going to solve this is exactly the same as if we had an equation there, well, with an equal sign, obviously. But with this one, if you times or divide by a negative, you've got to flip the sign. We're not going to be doing that in this one, but that would be one of the differences. So we're going to take away 10 both sides to get 7x on the left-hand side. Make sure you don't put an equal sign in there, otherwise that is instantly 0 marks. Then we're going to divide by 7 both sides to get x on its own. So it's x is greater than or equal to 11 would be the answer. So we're just going to copy this out first of all. So we've got x equals y over 15. Now we're asked to make y the subject, which means we want y on its own. What's stopping y from being on its own? Well, it's divided by 15. That's what over means. It means divide. So how do we get rid of that divide by 15? Well, we do the inverse or the opposite, which is times 15. So we're going to times both sides by 15. X times 15 is 15x, and it will get rid of this fraction here and just leave y. So y is 15x. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the two parallel sides here, which just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore, the radius would be half of that, which is 7. And the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938, blah, blah, blah. Now keep that in my calculator, because next thing we'll do is the shaded area part. And it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93, blah, blah, blah. And when you do that, you get 140.061, blah, blah, blah. It says it wants it to 2 decimal places, so it would be 140.06. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now, it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55. And it's going to be 0.55 times the amount of days. Well, it says the amount of days is X. So it's going to be 0.55x. Then it says that there's just a one-off cost of £15. So you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. So in this question, we've got a right angle triangle and we're asked for length BC and we're given the other two lengths. It's going to be Pythagoras. And so for Pythagoras, I just label the sides A, B and C, but C must be the one opposite the right angle. And Pythagoras says that A squared plus B squared is equal to C squared. We don't know what A is squared, but we know what B is, which is 5.2, and we know C is 11. So when we do that, we get A squared plus 27.04 equals 121. And we just solve. So the first thing I'm going to do is take away the 27.04 from both sides. So we get A squared equals 93.96. There we go. And to work out what A is, we just square root both sides. So it'd be A equals 9.693 blah blah blah. Asks us to do 2 decimal places, so we write 9.69. It's important to remember our speed distance time triangle. So we've got speed equals distance over time. And here we are given a distance because from here we're 16 kilometers away from home. So the distance, let's just draw another triangle, the distance will be 16. And we're told that the speed is 32 kilometers per hour. So the speed is 32. So to find the time, we're going to do 16 divided by 32. So the time is a half an hour. And half an hour would bring us, if we start here, half an hour would bring us to 2030 because it's 8 o'clock where we start and we end, therefore half an hour later. So here we can just draw in 2 extra lines and we can see that it makes a right angle triangle. And we're asked to find the length of the line segment AB. So we're asked to find what this length here is going to be. And we know what the other lengths are. We know that this is 2 and this is 3. So we're going to be using Pythagoras. And Pythagoras, we start by labelling the sides A, B and C must be the one that's opposite the right angle. And so we know Pythagoras is A squared plus B squared equals C squared. A is 2, B is 3, and 2 squared plus 3 squared is going to be 13. And then we're just going to solve that by square rooting both sides. So the square root of 13 is 3.605 blah blah blah. And it asks it to 2 decimal places, so it's going to be 3.61. When something is squared, you times it by itself. So another way of writing this is 6x to the power of 7 times 6x to the power of 7. The 6's can go together, and the x to the power of 7's can go together. And 6 times 6 is 36. And x to the power of 7 times x to the power of 7. When you times powers, you add them. So 7 plus 7 is 14. Something else you could have done is just squared the 6 to make 36. And one of the rules is that if you have a power on the inside of a bracket and a power on the outside of the bracket, you multiply them. So 7 times 2 is 14. The first thing we can do is work out what the circumference of the full circle would be. Obviously we haven't got a full circle here, but what the circumference of the full circle would be had we got a full circle. So that's going to be pi times the diameter. The diameter is twice as big as the radius, and this 21 centimeters here is the radius of a full circle. So that's going to be pi times 2 lots of 21, which is going to be 42 times pi, which is going to be 131.946 blah blah blah. Now we don't have a full circle here. We've got to work out what fraction of a circle we have. Well, we obviously have a quarter of a circle. So to find the arc length, which is this part here, it's like a part of a circumference, to find the length of the arc, what we're going to do is just get that circumference and we're just going to divide it by 4. So we're going to get the 131.946 blah 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 and divide it by 4. When we do that, we get 32.986 blah blah blah. Now that's not what the perimeter is. Perimeter is the total distance around the circle. So we've also got to add on the 2 parts here, the 2 radii here, to get the full distance around the circle. So the perimeter is going to be the arc length plus a radius plus a radius. So that's going to be 32.986 blah 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 plus 21 plus 21, which equals 74.986 blah blah blah. And when we round that to 2 decimal places, we get the answer of 74.99. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid. And we're going to do x minus 15 at the top, x minus 15 at the bottom. Then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x. Same again here. And then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line, and we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is I want the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we're going to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. So we're going to start off with 100%. And it says that the card depreciates. That means goes down by, so it goes down by 1.7% every year. So we do 100 take away 1.7, which is 98.3, and that's percent. And we want that as a decimal, or as a multiplier we call it. And so we just divide it by 100 to make it into a decimal, 0.983. And that's our multiplier. And the beautiful thing about a multiplier is we just need the amount of years. Well, it says from 1980 to 1985, so that's going to be 5 years. So it's going to be 5 years. And so what we do is we get the original amount, which was 2,245, and times it by the multiplier 5 times. Now, I can't be bothered on my calculator to times it by 0.983 5 times. So what you can do is you can do it to the power of 5, which basically means the same thing. That gives us 2060.553. And when we round that, that would be £2,060 and 55 pence. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So A plus B minus C will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is, as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different, which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. We're going to start by focusing on the A and B, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16, and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions or solution, because they're both linear, will just be where the 2 graphs cross. So this here will be our solution. So x is 2 and y is -4. When drawing a quadratic or a cubic or reciprocal graph, you've got to make sure that you find as many coordinates as you can with curves. With a linear graph, the minimum you need is 2, and we normally take 3 coordinates. With a curve, we need loads. So I'm going to pick loads of x coordinates. So I'm just going to pick all of the integers. Lots and lots. And I'm going to find out what the y coordinate is. So for the first one, I'm going to put in, on my calculator, a quarter times brackets -4, close brackets, +4, and all of that in brackets. Then I'm going to do the second bracket. So I'm going to put bracket -4, close bracket, -1, close bracket. And then bracket -4, close bracket, take away 4, close bracket. Okay? So I'm just going to put in bracket -4 each time you see an x here. When you do that, you get the answer of 0, which makes sense because -4 plus 4 is 0, and whenever you times something by 0, it will get to 0. Then I'm going to do the same with -3, and I get 7. Same with -2, I get 9. Same with -1, I get 7.5. Same with 0, I get 4, and 0, then -3, then -3.5, and at 4 I get 0, then 9, and then 25. Now that last one, the 25, is not really that helpful because the axis only goes up to 16. So the next thing is I'm going to plot them. So -4 is at 0, so that'll be here. -3 is at 7, so that's going to be halfway here. Then we're at 9, which will be halfway here. 7.5 is a bit more interesting because it's halfway between 7 and 8. So it would be about here. Then 4. Then 0. So it looks like it's going to go down now, but it's going to go down for a little bit, like down here where it's -3, and even further down here where it's -3.5. But then it starts going up again. So 0, and then 9, and then we're off. We're off the top. So the next thing we need to do is join that. Now it's sometimes easier if you turn the page sideways. It depends on the curve. I can't turn this sideways, so mine's hopefully going to look okay. And it's one continuous curve going through all the points. And so we're going to try our best here. And it's not easy for me because I can't quite see the points. You shouldn't take your pencil off at all. Just I have to because my hand gets in the way. And then we know it shoots up from here. Now, that doesn't look the best curve in the world, but as an examiner, what am I looking at? I'm looking at the fact that it goes through all the points, which it does. I'm looking at the fact that there's no obvious gaps, which there isn't. It stops here, but it goes off the top of the graph here, so that's fine. I'm looking for no feathering, which is where you do kind of that with the pencil. No, there's no feathering there. There's a little bit of a wavy bit there, but I think a lot of students get worried that they're going to lose marks unless it's perfect and they start rubbing it out. like if you've missed a coordinate and you've kind of gone around something, then yeah, maybe rub it out. Or if you've got feathering, or if it just goes, if you knock your hand and it goes off or whatever. But unless it's awful, unless it's not going to get the marks, just leave it. If it's a bit wavy, if it's a bit weird round here, and I think, you know, it's not perfect around this bit either, don't worry about it, leave it, it'll still get the marks. Yes, this one doesn't quite go through the coordinate, but it's close enough. And you know, I think that students often, when I'm marking, I see that they've rubbed it out several times, and where I can see it still there, it was fine. It was going to get the marks regardless, and so it's wasted time, and it just makes it look a bit messier. So, it doesn't have to be perfect. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.